The Kentucky Uniform Electrical Wiring Guide, or UEWG, mandates that 20 ampere small appliance branch circuits serve all receptacle outlets, with a maximum of 4 per circuit, including refrigeration equipment, in the kitchen, pantry, breakfast room, dining room, or similar area of a dwelling unit. This requirement is specific to the Kentucky UEWG and is not found in the National Electrical Code, or NEC. The NEC stipulates that small appliance circuits must be rated for at least 15 amps and can have a maximum of 13 receptacle outlets. The NEC requirements for small appliance circuits are as follows. Firstly, small appliance circuits must be rated for at least 15 amps. Secondly, small appliance circuits can have a maximum of 13 receptacle outlets. Thirdly, receptacle outlets on small appliance circuits must be spaced at least 6 feet apart. Fourthly, small appliance circuits must be protected by a circuit breaker or fuse. Fifthly, small appliance circuits cannot be used to supply fixed appliances, such as ranges, ovens, or dishwashers. Let's delve deeper into each of these NEC requirements. The first requirement, that small appliance circuits must be rated for at least 15 amps, ensures that the circuit has sufficient capacity to handle the load of multiple small appliances. A 15 amp circuit at 120 volts, for example, can theoretically supply up to 1800 volt amps. However, it is crucial to consider derating factors and continuous load calculations as per the NEC. The second requirement, limiting small appliance circuits to a maximum of 13 receptacle outlets, prevents overloading the circuit and ensures safe operation. This limit helps distribute the load and minimize the risk of tripping the circuit breaker. The third requirement, spacing receptacle outlets on small appliance circuits at least 6 feet apart, encourages even distribution of appliances and prevents concentrating the load in one area. This spacing also reduces the likelihood of extension cords being used, which can pose a safety hazard. The fourth requirement, protecting small appliance circuits with a circuit breaker or fuse, is a fundamental safety measure. Circuit breakers and fuses are designed to interrupt the flow of electricity in the event of an overload or short circuit, preventing overheating and potential fires. The fifth requirement, prohibiting small appliance circuits from supplying fixed appliances, is intended to prevent overloading the circuit and to ensure that fixed appliances have dedicated circuits that are properly sized for their specific loads. Fixed appliances, such as ranges, ovens, and dishwashers, typically require higher amperage circuits than small appliances and should not be connected to the same circuit. Now let's consider a practical example. Imagine a kitchen with a refrigerator, a microwave, a toaster, and a coffee maker. These appliances would typically be plugged into small appliance circuits. According to the Kentucky UEWG, if the kitchen is in Kentucky, these appliances must be served by 20 ampere circuits with no more than 4 receptacles per circuit. The NEC, however, would allow for 15 ampere circuits with up to 13 receptacles, provided the load calculation does not exceed the circuit's capacity. It's important to understand the concept of load calculation when designing electrical circuits. Load calculation involves determining the total amperage draw of all appliances and devices that will be connected to the circuit. The NEC provides specific guidelines for load calculation, taking into account factors such as appliance wattage, duty cycle, and continuous versus non-continuous loads. For example, a refrigerator is considered a continuous load, meaning it operates for 3 hours or more at a time. According to the NEC, continuous loads must be derated to 80% of the circuit's capacity. This means that a 15 amp circuit can only handle a continuous load of 12 amps. Similarly, a 20 amp circuit can handle a continuous load of 16 amps. When calculating the load on a small appliance circuit, it's important to consider the wattage of each appliance and convert it to amperage using the formula amps equals watts divided by volts. For example, a 1200 watt microwave operating on a 120 volt circuit draws 10 amps. A 600 watt toaster operating on a 120 volt circuit draws 5 amps. A 900 watt coffee maker operating on a 120 volt circuit draws 7.5 amps. A refrigerator typically draws between 1 and 3 amps depending on its size and efficiency. In our example kitchen, the total amperage draw of the microwave, toaster, and coffee maker is 22.5 amps. If the refrigerator draws 2 amps, the total load in the circuit would be 24.5 amps. This exceeds the capacity of a 15 amp circuit, even without considering directing factors. Therefore, in this scenario, a 20 amp circuit would be necessary. It's also important to consider the potential for future loads. If the homeowner plans to add additional appliances to the kitchen, the circuit should be sized accordingly. Overloading a circuit can lead to overheating, tripped circuit breakers, and even fires. In addition to load calculation, it's important to follow all other applicable requirements of the NEC and the Kentucky UEWG. This includes using the correct wire size, installing the correct type of receptacle, and properly grounding the circuit. The NEC specifies minimum wire sizes for different amperage circuits. For example, a 15 amp circuit typically requires 14 American wire gauge copper wire, while a 20 amp circuit typically requires 12 American wire gauge copper wire. The NEC also specifies the types of receptacles that are allowed on small appliance circuits. Typically, standard 15 amp or 20 amp receptacles are used. Grounding is a critical safety measure that helps protect against electric shock. The NEC requires that all electrical circuits be properly grounded. Grounding provides a low resistance path for fault current to flow back to the source, causing the circuit breaker to trip and energize the circuit. It's important to note that the NEC is a minimum standard and local jurisdictions may have additional requirements. In Kentucky, the UEWG is more stringent than the NEC in some areas, such as the requirements for small appliance circuits. Therefore, it's essential to consult both the NEC and the local electrical code before designing or installing any electrical wiring. In summary, the Kentucky Uniform Electrical Wiring Guide requires 20 ampere small appliance branch circuits to serve all receptacle outlets, with a maximum of 4 per circuit, including refrigeration equipment, in the kitchen, pantry, breakfast room, dining room, or similar area of a dwelling unit. This is a stricter requirement than the National Electrical Code, which only requires that small appliance circuits be rated for at least 15 amps and can have a maximum of 13 receptacle outlets. When designing small appliance circuits, it's crucial to perform a load calculation, follow all applicable requirements of the NEC and the local electrical code, and use the correct wire size, receptacles, and grounding methods. Always consult with a qualified electrician if you have any questions or concerns about electrical wiring. Article 422 of the NEC provides further guidance on appliance branch circuits. Section 422.10 covers branch circuit sizing, specifying that branch circuits supplying appliances must have an ampacity sufficient for the appliance load served and must not be less than 15 amps for appliances rated 13 amps or more. Section 422.11 covers overcurrent protection, requiring appliances to be protected against overcurrent in accordance with the listing and labeling requirements. Section 422.12 addresses the installation of appliances, specifying that appliances must be installed in accordance with their listing and labeling instructions. It's also important to consider the location of receptacles in relation to countertops and other surfaces. The NEC has specific requirements for receptacle placement to ensure that they are accessible and conveniently located. Receptacles must be located within a certain distance of countertops and work surfaces to prevent the need for extension cords. The NEC also addresses the use of ground fault circuit interrupters, or GFCIs, in certain locations. GFCIs are designed to protect against electric shock by detecting small imbalances in current flow. GFCIs are required in bathrooms, kitchens, and other areas where there is a risk of water exposure. When working with electrical wiring, it's essential to follow all safety precautions. Always turn off the power to the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electrical wiring, it's best to hire a qualified electrician. Electrical work can be dangerous, and it's important to ensure that it is done safely and correctly. Remember that electrical codes are constantly evolving, so it's important to stay up to date on the latest requirements. The NEC is typically updated every 3 years, and local jurisdictions may also adopt changes to their electrical codes. By following the requirements of the NEC and the Kentucky UEWG, you can ensure that your small appliance circuits are safe, reliable, and compliant with all applicable regulations. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. The correct installation and maintenance of electrical systems are crucial for protecting people and property from electrical hazards. Improper wiring can lead to fires, electric shock, and other serious injuries. It is always advisable to seek professional help when dealing with electrical work. Remember that the information provided here is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific guidance on your electrical wiring project. They can assess your specific needs, perform load calculations, and ensure that your wiring is safe and compliant with all applicable code and regulations. Furthermore, consider the energy efficiency of the appliances you choose for your kitchen. Energy-efficient appliances can save you money on your electricity bill and reduce your environmental impact. Look for appliances with the Energy Star label, which indicates that they meet certain energy efficiency standards. In addition to the NEC and the Kentucky UEWG, there may be other applicable standards and regulations that you need to consider. For example, the Americans with Disabilities Act, or ADA, has requirements for the accessibility of electrical receptacles and other electrical components. If you are designing a kitchen for someone with disabilities, you need to ensure that the receptacles are located at a height that is accessible to them. It's also important to consider the aesthetics of your kitchen when choosing receptacles and other electrical components. There are many different styles and colors of receptacles available, so you can choose ones that complement your kitchen decor. However, it's important to prioritize safety and functionality over aesthetics. Always choose receptacles that are listed by a recognized testing laboratory, such as Underwriters Laboratories or all. UL listing indicates that the receptacle has been tested and meets certain safety standards. When installing receptacles, it's important to follow the manufacturer's instructions carefully. Receptacles should be properly wired and securely mounted in the wall. Loose or improperly wired receptacles can be a fire hazard. It's also important to protect receptacles from moisture and damage. Receptacles that are located near water sources should be protected by GFCIs. Receptacles that are located in high-traffic areas should be protected by covers or guards. Regular maintenance of your electrical system is essential for ensuring its safety and reliability. Inspect your receptacles regularly for signs of damage or wear. Replace any damage to worn receptacles immediately. Also, check your circuit breakers periodically to ensure that they are functioning properly. If a circuit breaker trips frequently, it may be a sign that there is an overload in the circuit. If you suspect that there is a problem with your electrical system, it's best to call a qualified electrician. Do not attempt to repair electrical problems yourself unless you are a qualified electrician. Remember that electricity can be dangerous, and it's important to take all necessary precautions to protect yourself from electric shock and other electrical hazards. By following these guidelines, you can ensure that your small appliance circuits are safe, reliable, and compliant with all applicable regulations. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns.